Hello and welcome to the presentation video of Group 73. Today we present Osmowsis, a lawnmower simulator. We are a group of 5, but the assignment was executed by the 4 of us listed in the slide: Shantanu, Dylan, Sumik, and Ketan. We start off the presentation by going over the class model diagram. So we built our class model diagram based on individual implementations from assignment 4. We try to incorporate features from individual class model diagrams that help the overall system. We define obstacles as an interface. The main reason for this is if in the future there are different various other obstacles, then we can just implement classes to extend the interface and we are good to go. So that's one reason why we define obstacles as an interface. So currently we have two classes, creator and puppy, which extend the interface. Creator class is a static obstacle. It only has attributes for position x and y. The puppy class represents a dynamic object. It has different attributes. The move chance is an attribute that denotes it's basically the likelihood of the puppy moving at a particular turn. The scan for adjacent squares method is used by the puppy to gather a list of squares which are eligible for move. So internally, the scan for adjacent square uses these methods, check direction methods, which give a list of valid squares to move. The move method uses this list of directions to move, and it randomly picks one direction to move for the puppy. And as I said, the move chance is used to determine when the puppy should move. So it's based on, so we randomly select the number from 0 to 100, and if that number is less than move chance, then the puppy object would move. Moving on to the lawn, the class is very simple. I think the attributes and methods are self-explanatory. The lawnmower class has the logic for the lawnmowers, the automated lawnmowers. So the automated lawnmower logic is explained later in the video. But for now, let me go over the attributes. The main change is the observed lawn state. So this is new for assignment 4. So because now mowers can have a common knowledge of the observed lawn, we introduce the observed lawn state as an attribute for each lawnmower. The reason we did that is to make things simple. Instead of creating a separate class, this was easier for both the lawnmower and the simulator. The simulator class manages the simulation. It keeps track of number of turns. It queries the mowers and the puppies, and for each move, and then for each move it validates that it was indeed a correct move for that turn. The real lawn attribute represents the actual lawn, whereas the observed lawn is the observed lawn state for coming in from the lawnmowers. So this is the main copy of the observed lawn. So at each turn, the mowers update this observed lawn attribute using the update observed lawn method. So this was pretty much the class model diagram for our system. Our deployment diagram is as follows. So we have a GUI class which is implemented using Java Swing, and that handles the front end of the system, whereas the class model diagram represented previously handled the actual system logic. The scenario.csv is the input file to the system. So this is the actual simulator software, the GUI, the front end of our system. So on the left, we have the legends which represent the different lawn squares. So the tall grass is the uncut grass, the short grass is the cut grass, and uh, the puppy on top of those two represents a puppy on a cut grass and a puppy on an uncut grass. The gray circle with two holes is the crater, represents the crater. The yellow tractor like object represents the lawnmower, and the puppy on the lawnmower represents a square in which the puppy and the lawnmower exist together. The colors around the squares represent the the state of the mower. So if the mower is yellow, then the mower has stalled. If the mower is red, the mower square is red, then the mower has crashed. And if the mower square is gray, then the mower is off. The black line represents the fence, and the blue line around the square, around the object, represents which object is being pulled. The buttons on the bottom, fast forward runs through the simulation without input, and next turn goes through the simulation each step at a time, each turn at a time. Stop button is to stop the simulation. The how to simulate gives you instruction to run the simulation. The counters on the top move represents the number of moves. Cut grass represents the number of total grass squares cut, and uncut grass represents the total number of uncut grass squares. The move log on the right is showing the textual output from the terminal. So let me run through a turn and the move log should start populating. So right now the first object to pull is this is mover 1. So once I hit next turn, it'll query the mover 1 for its action. The mover returns scan, and the result of the scan is listed in the output. So north is crater and the remaining squares are grass. The next turn, so now the next turn, well, this is not the next turn, this is the same turn, the second object, which is mover 2. That's why mover 2 now became blue, the square around mover 2. So now mover 2 also requested a scan and it got a scan. So let me jump through some. So now all the objects have queried and some objects are making the move. So this lawnmower made 2 moves northeast, as you can see here. Now this one is requesting a scan. So this continues, and if I hit fast forward, then it gives us command an output saying that the simulation is complete, and I can check the terminal for the output. So total number of turns is moves is 69, total number of grass cut is 64, uncut grass squares are 11, and I can open the terminal to see the same output. So that is the simulation run for this scenario. As you see at the end, this mower has crashed, the others have turned off. Next we show a scenario where 2 mowers are next to each other. We have modified the simulation software to show this case. So the simulate mower crash button basically moves the mowers next to each other. So now the next object to pull is this mower, and now this mower has a mower next to it. So in this scenario, the mower chooses the next move to stall. So the mower doesn't take any action until this mower has moved away from it. So if we continue along this path, eventually the mower moves, and now the original mower would have gone out of the start state.